All right, in this assignment we're going to be dividing polynomials, but before we do, it's important to understand the different parts of any division problem. First you've got the division symbol, which is half of a rectangle, and then up under the division symbol you've got your dividend. Just outside of the division symbol is the divisor, and above it, your result is called the quotient. Sometimes there's a remainder, sometimes their remainder is 0. So we're going to be looking at two methods, the first of which is going to be long division, which works for all divisors. So we're going to address this one first. Whenever you're doing long division, first thing you want to do is check for placeholders. See if there are all the terms in the dividend and in the quotient in the divisor. They should all be in descending exponential order. If you're missing one of the exponents, then you just need to add that term with 0 as the coefficient. And then you ask yourself, what does the lead term in the divisor need to be multiplied by to get the lead term in the dividend? And you multiply all the terms of the divisor by that number, by that quantity. Then you subtract those products from the like terms in the dividend. And then you repeat those steps, starting at step 2, all the way till you get to the last term in the dividend. And then if there is a remainder, you put a plus or a minus, depending on if the remainder is positive or negative, and then write that over the divisor. If the remainder is 0, that tells you that the divisor is a factor of the dividend. Now, synthetic division, it's a faster process. However, it doesn't work. You can't use synthetic division in all scenarios. You can only use synthetic division when the divisor is in the format variable plus or minus a constant. So first thing you're going to do again is check for placeholders. Then you're going to set the divisor equal to 0 and solve. Once you solve for the value of the variable, when you set the divisor equal to 0, you're going to put that quantity inside the box. And then you're going to write all the coefficients for the dividend. Again, adding any placeholders, zeros for any placeholders. You're going to bring down the first coefficient, then multiply the box numbered by that first coefficient. Place the product under the next coefficient. Add those two numbers, and then repeat till you get to the last term in the dividend. You're going to add the variables at the very end. It should be 1 degree less than the degree of the polynomial. All right, so we want to divide this polynomial by 8n. So we're going to use long division. Alright, so as you can see, all the exponents are in descending order, so we do not need to add any placeholders. So what I need to multiply 8n by to get 8n to the 4th power is n cubed. I should write that above the next term in the dividend. I'm going to multiply that n cubed by everything in the divisor. N cubed times 8n is 8n to the 4th power. Add those, subtract those two terms, and we get 0. Bring down the next term, and then repeat. What do I need to multiply 8n by 2n squared to get 16n cubed. When I multiply 2n squared by 8n, I get 16n cubed. Subtract those, I get 0. And then I need to multiply 8n by n to get n squared. I need to multiply 8n by 1/8 n to get n squared. And when I subtract them, I get a 0 remainder. That lets me know that 8n is a factor of 8n to the 4th plus 16n plus n squared. All right, next example, we're also going to do by long division. So let's see, we've got 8n cubed. Next term is 4n squared, so no placeholder needed right there. However, you can see that there is no n to the first power term, so we need to add a placeholder. And then lastly, the minus 9. So what do we need to multiply n by to get 8n cubed? That would be 8n squared. Multiply the 8n squared by the n and by the 6. We get 8n cubed plus 48n squared. Change the signs of both the numbers in the bottom and then add them up. It's the same thing as subtracting. When we do the n squareds, they go away. We get 0n squared. Bring down the next term. To get 0n squared, I need to multiply n by 0n. So when we multiply 0n by n and 6, we get 0n squared plus 0n. Change the sign of the bottom row and add them up. We get 0n, bring down that last term. We need to multiply n by 0 to get 0n. And then 0 times n plus 6 is just 0n plus 0. Change the signs of the bottom row, add them up, and we get negative 9 as our remainder. So we write negative 9 over the divisor. Now getting rid of the placeholders, we should have 8n squared minus 9 over n plus 6. All right, and this is going to be the last one that we use long division for. You can't use synthetic division for this one because the format for the divisor, the polynomial in the denominator, is not appropriate for synthetic division. So there's no placeholders needed in the divisor. There's no placeholder needed after that first term. There's no placeholder. There is a placeholder that's needed after the second term because we're missing that x squared term. So we're going to add a placeholder, and then the minus 9x, and then the last term is the constant. So to get 5x to the 4th, we have to multiply x squared by 5x cubed. I'm sorry, 5x squared. And so we can multiply 5x squared by all the terms in the divisor. And we get 5x to the 4th minus 15x cubed plus 20x squared. Change the sign of the bottom row and add them up. And then bring down that next term. To get 17x cubed, we have to multiply x squared by 17x. So we have to multiply now 17x by all the terms in the divisor. Change the sign of the bottom row and add them up. Bring down that last term. And then ask yourself, what do you have to multiply x squared by to get 31x squared? And the answer is 31. Multiply the 31 by all three terms in the divisor. Change the sign of the bottom row and add them up. And that is our remainder, 16x minus 124. So the 16x is positive, so we just write plus, and then 16x minus 124 over the divisor, which is x squared minus 3x plus 4. Now the last two examples, we're going to use synthetic division. All right, so we set the divisor k minus 2 equal to 0, and we get k equals 2, so we're going to put 2 in the box. And then write down all the coefficients for the dividend. Notice we do not need any placeholders because we have a k squared, then k, and then a constant. So we bring down that first coefficient, multiply 2 times 8, we get 16. Add those up, and we get 1. 1 times 2 is 2. Add negative 4 and 2, and we get negative 2. That's our remainder. So now we just need to add the variables onto those coefficients. The first term, the first coefficient should be 1 degree less than the first term in the dividend. So that 8k in our quotient, it should be that 8 should have a k next to it. And then the 1 is just our constant. 8k plus 1, and then our remainder is minus 2 over k minus 2, our divisor. And since we had a remainder, we know that k minus 2 is not a factor of that polynomial. All right, last example. Again, we're going to use synthetic division. We're going to set the divisor equal to 0. So when we set a minus 5 equal to 0, we get a equals 5. We're going to add that to the box and then write out all the coefficients of the dividend, adding any placeholders. So we have a to the 5th, a to the 4th, a to the 3rd, a to the 2nd, a, and then the constant, so no placeholders needed. Bring down that first coefficient. 5 times 4 is 20. Add those two terms up, and we get negative 10. 5 times negative 10 is negative 50. Add those up, and we get positive 5. 5 times 5 is 25. Negative 16 plus 25 is 8. 5 times 8 is 40. Negative 35 plus 40 is 5. Then 5 times 5 is 25. Negative 24 plus 25 is 1. That's our remainder. All right, so now we just need to add the variables onto each one of those coefficients. Again, that first term, the 4, is going to have a variable of a to the 4th power, 1 degree less than the dividend. So a to the 4th minus 10a cubed plus 5a squared plus 8a plus 5. And since the remainder is positive, plus 1 over the divisor, which is a minus 5. And again, this is not a factor of that polynomial because we got a remainder. Anytime you get a remainder, it's not a factor.